Hello, I'm Lior from Tel Aviv University and Facebook Research. I'm going to present two projects today. The first one is about the Dead Sea Scrolls. So at Tel Aviv University, we have a long tradition of working with the humanities on various projects. The Dead Sea Scrolls is one of them. And the goal of the project in general is to be able to read the images, understand the images, understand handwriting, and so on. What I'm going to present today is a bit more limited. It's about matching between images captured in the 50s, when the Dead Sea Scrolls were first found near the Dead Sea. And these images had the scrolls in a better condition than what they were, of course, 50 years later on. But the imaging was much less detailed, earlier technologies, and so on. Then a few years ago, they captured everything together, everything again. In this case, with multispectral imaging, much higher resolution, much higher quality. The problem is the fragments between the two captures. It's kind of hard to find which is which because things have shifted, things were lost, things were recategorized, and so on. So what we do, basically apply classical computer vision over here. We detect the ruler so that is going to one day analyze these images. They were captured in kind of a hurry and they're not of great quality. And people try to save film by taking fewer images of more fragments. So we do classical computer vision, we edge detect, we compute components, and then we create a training set by basically applying grabcut in order to get components that are without the shadow and so on. And then we want to do the segmentation automatically to all fragments. So what we do is we train a deep neural network. In this case, the architecture is a unit. The input is the fragment or a patch of the fragment. The output is the segmentation mask that we obtain. So this was the preliminary step of obtaining the fragments. Then if you actually want to perform matching, what we do is we have two steps. The first step is to basically just filter the potential matches based on size and approximate shape. The second step is to use sift flow in order to find the correct patch and match between the old and the new one. So, as I said, we are working with humanities for quite a lot of time right now. We find it very satisfying. They tend to really appreciate what we are doing for them. It's a bit hard to be novel because the problems are very practical and very applied. We try to do our best to come up with systems that the archaeologists, the historians, and the scholars can actually benefit from. So this was the first presentation. Let me just shift into another one.